Good morning, dear students. Yesterday, we have discussed something about the EMF of the cell, the Nernst equation, and along with that, we have studied its relationship with the Gibbs free energy and the equilibrium constant. Today, I am going to take one more interesting topic for all of you, and that is very easy. And in this topic, very easily you can learn the questions. Even again, I am saying this is again the topic where the numerical problems you can solve in the fraction of the seconds. Very easily you can learn how to solve the numerical questions. Good morning, everyone. I think you all can see there is something written on the board, and this is written with the equation and the value. Now I am coming to this. What is our topic? The topic for the class is electrochemical series and its application. If its topic is series, that means definitely it is an arranged system. It is a proper lineup system, right? And whenever you arrange any of the thing, since you are arranging here the elements and the criteria for this arrangement, what you have to take, this is important thing here. In the beginning, when I started this chapter, I introduced you all with the electrode potential. Two terms I have used. One is the oxidation potential and the other is reduction potential. And that time I taught you that our IUPAC, the International Union of Pure and Applied Chemistry, have now set the standard rules. And as per this standard rule, the potential is always written in the terms of the reduction. And for using the word standard, we have to standardize the conditions. And I think you all remember now, so many times we have discussed the standard condition is whenever the electrolyte solution has the concentration 1 capital M, 1 molar, and the temperature is 298 Kelvin along with the pressure 1 atmosphere. So in this condition, the standard electrode potential of different elements have been measured, and then on the basis of the value of the standard electrode potential, the elements are arranged in a series, in a sequence, and this sequence is called the electrochemical series. It has its wide application. The application part is extremely important here. The arrangement is very simple. First task, I just want to ask one question: how you can find out the standard electrode potential of any of the element? I think you remember that always a cell is there, one half cell for the oxidation and another half cell for the reduction purpose. One is behaving as the cathode and other is behaving as the anode. And the cell potential that you obtain in the voltmeter or the ammeter, that is the device that you all are using, is measuring the difference of the electrode potentials of cathode and anode. So here, if you want to find out the standard electrode potential of any of the element, for the reference, what you have to use? You have to use the SHE, she. And this SHE stands for standard electrode, hydrogen electrode. And why this is standard, why it is used as the reference? Because its own electrode potential is 0, and this is given by the IUPAC. It's not calculated. The time I taught you the standard hydrogen electrode, I taught you this, that IUPAC has assumed, it has not calculated, it has assumed that the value of electrode potential of standard hydrogen is 0, and in this condition, if a cell is constituted in such a way that one electrode, it may be anode, it may be cathode, depending upon the other reference electrode, the EMF of cell or the cell potential that you will obtain in the cell will be only the cell potential, the electrode potential of the other electrode, as you have here. Here you can see the value. I have distinguished it purposefully so that you can identify. Hydrogen, here you can see 2H plus 2 electron, H2, this is the standard hydrogen electrode, and the higher potential is 0. Above to this, you can see the values are positive. Below to this, you are seeing the values are negative. So, on the basis of the standard hydrogen electrode, when a cell is constituted with using any of these elements as the other electrode and they are dipped in their own electrolytic solution, that time the cell potential that you obtain from the cell is considered as the standard electrode potential of the elements. And based on the values, right, I have written only some examples here. There are lots of examples and they are given in your NCERT book as a series. From there you can refer it, and the only task for you people is to remember this electrochemical series. And for this I will prepare another video for shortcut tricks, and I will give you the links for that. Mnemonics are there, and with the help of the mnemonics, you can learn the sequential order of these elements. So here what I have done, you can see here, this is part, what the chemical change is taking place, and this is the part where the standard electrode potentials are given in the terms of the volt. In the volts, standard electrode potential is given. And if you see the top one, which is the fluorine, the most electron negative element of the periodic table, it has the standard electrode potential plus 2.87. And this is just students, the standard electrode. This is the student's standard electrode potential in the terms of the reduction. All the potentials are used in the terms of the reduction only. And for the oxidation purpose, if you want to express in the terms of oxidation potential, you just have to change the sign. Oxidation potential and reduction potential, by the magnitude, they are always same. The only difference is in their sign. The positive converts into the negative and negative is changed into the positive. The topmost position in this series with the highest value 2.87 is obtained by the fluorine. Now I'm moving down and down. Au with 1.40, then oxygen. Here this is very important. The water I have written at the two places, if you can see here. One place here and one place here. This is a very important term because water behaves as oxidizing as well as the reducing agent. That's why at two places you will find it, and definitely I will take the example of the questions when you will know its importance. Then mercury, silver, copper, these elements are silver, copper 0.34, the smallest positive value for any of the element. The next one is the hydrogen that has its value 0, neither positive nor negative. That's why used as the reference electrode. Now again you see Here the values in the negatives are increasing, that means their absolute values are decreasing. The last one is the lithium with the value minus 3.05. That means you can come to the conclusion that all these elements are arranged in the decreasing order of their electrode potential from top to bottom. As you are moving from top to bottom, what you see that they are arranged in the terms of decreasing value of the electrode potential or standard potential. Here, one suggestion I want to give you all, that in different books, the series is given in the different order. Some books they start from the lithium and they finish to the fluorine, and vice versa. As I have taken this because in the NCERT book the sequence is given in this way. So I just suggest you just take the reference from the NCERT book and only in one direction study all the properties. If you will study the properties top to bottom and bottom to top, you will confuse which property is going to increase and which property is going to decrease. So just decide one direction only, and in that particular direction you have to study it. Application part will be easier for you people, right? So here this series, the series of the different elements arranged on the basis of their standard electrode potential, that is measured with reference to the standard hydrogen electrode, is known as the electrochemical series, right? Clear all of you guys? Now I think I can come to the application part, right? What is the electrochemical series? Electrochemical series is the arrangement of different elements on the basis of their electrode potential. As we move top to bottom, the electrode potential decreases, right? The very important thing is standard electrode potential, that is the standard reduction potential, decreases, right? Now you have to understand what are the properties and how you can use these properties for your practical purpose. When you will move top to decreases, always write it, and please never forget this point. As you will move bottom to top in the upward direction, from here you can decide whether the given set of the only, right? Oxidizing agent, it's not the oxidized, which is oxidizing agent that undergoes the reduction reaction. Agent, that means that gets the work done. I think you remember the example of the ticket agent. So many times I have given at the time of teaching oxidizing reagent and reducing reagent. A travel agent, does it traverse itself? No, it doesn't travel itself. He doesn't traverse it himself. But what he do? He just makes the arrangement for the traveling of the others. Similarly, this species will not undergo the oxidation, but it will make the oxidation process easier, right? This will facilitate to the oxidation process. That means what is oxidation? Losing of the electron is oxidation. If some recipient is there, then the losing of electron will become easier, right? So definitely for this purpose, the species itself will undergo the reduction reaction. It will gain the electron. Clear? So here the oxidizing strength increases. That means its own ability to get reduced also increases. And my dear students, if you forget, I'm giving you the one hint. You can see here it is the non-metal, and here at the bottom it is a metal and most electropositive element of the periodic table. Definitely this will have the ability to lose the electron. That means this will undergo the oxidation reaction, fluorine being the most electronegative element of the periodic table. What it will have the tendency? It will have the tendency to gain the electron, that means undergo the reduction reaction. So just from the top element and the bottom element you can remember, and that's why I always say that don't collect the knowledge, you just apply it also. Now the metallic and non-metallic properties, you know that metals are electropositive, they have the tendency to lose the electron, and non-metals, especially the fluorine, always and always has the tendency to gain the electron. So just from top and bottom elements, you can come to conclusion. Even you don't need to remember and go for mug up this property also. You just have to remember the top one is the fluorine and the bottom one is the lithium, right? So lithium, what it always has the tendency to lose the electron, that means this will be the strongest reducing agent and this will be the strongest oxidizing agent. This is one characteristic feature just by comparing the position of the elements, right? You can understand the things, you can solve the questions. Now I'm coming to the application part. The first application. The first application of this series is compare oxidizing and reducing strength. Compare oxidizing and reducing strength. My dear students, I hope you all are sitting with the pen and paper that I always instruct in all the questions, all of my sessions. Now I'm coming with one question, and by that question, I will teach you this application part. See this question. Compare the oxidizing power of zinc and nickel. Two elements are given here, right? You have to compare the oxidizing power of them. The two elements given are here zinc and nickel. These two elements are given and you have to identify which will have the higher oxidizing strength or which will be a stronger oxidizing agent. Now I am giving you the hint how to solve these questions. In the question, one more thing I could do, that I could give you the value of E naught, but purposefully I have not given, right? Here, the first way to solve the question I am telling you, see, find out the position of zinc and nickel, right? Zinc is below to the nickel. Nickel is the position of the nickel is higher, superior to the zinc, right? So which one will be having a stronger oxidizing nature, which the power of which will be the more, that will be the nickel, and copper will, sorry, zinc will behave here as the reducing agent if this set of the elements zinc and nickel is used in an electrochemical cell, galvanic cell. In this case, here the oxidizing strength of the nickel is more. That means the reduction will take place in the nickel and the oxidation of the zinc will take place. So, my dear students, one question I am asking, can you tell me which will behave as anode and which will behave as the cathode? You all know that anode is the site of oxidation and cathode is the site of reduction. The electrode where oxidation takes place is always defined as the anode, and where the reduction takes place is defined as the cathode. In this set, the nickel is having more oxidizing strength. The power is greater as an oxidizing agent for this. That means this will undergo the reduction reaction, and definitely since reduction is taking place here, this will behave as the cathode and zinc will behave as anode. The very common example with which you are very familiar, I am taking here. You can see that our Daniel cell we have discussed, it is zinc versus copper. You can see here the position of copper is superior in comparison to the zinc. That means copper is having the higher or greater strength as an oxidizing agent, and you have seen in that the copper was getting reduced and was behaving as the cathode. So many times we have discussed throughout this chapter. So this is one application of the electrochemical series. You can compare the oxidizing and reducing strength of the different elements. And can you tell me which will be the most strong oxidizing agent from this? This will be fluorine, since it will always and always undergo the reduction reaction, and the weakest oxidizing agent is lithium. Since being electropositive element, it always have the tendency to undergo the oxidation reaction. Now I am giving you the second hint, right? If the table is there, you can compare the position. If the table is not given there, how you can compare, right? So second way of solving of this type of the questions, I am teaching you, dear students, and this is on the basis of the value of standard electrode potential. The element which will have, please note it down, I am stressing it, I am loudering my voice only so that you can come to the importance. Always and always remember this point: the element with higher value of the standard electrode potential will be a stronger oxidizing agent. Once again, I am repeating myself: the element with higher value of the standard electrode potential. The element for which the value, absolute value I am saying here, I does not mean here with the symbol. The value means the absolute value of the standard electrode potential, right? So the element for which the standard electrode potential is higher will be the powerful oxidizing agent, and the vice versa concept you can apply for the reducing agent, right? Always in the case of oxidation and reduction, you learn one thing only, either in the terms of the oxidation or in the terms of the reduction, and then you do the vice versa. In this way, you will not get confused, right? So this is a very important application of this electrochemical series. And what is its application in real life or in the industries or chemistry in everyday life? Whenever you have to undergo the process of metallurgy, or you want to obtain any element, you want to purify, which should be used as the oxidizing agent, which should be used as the reducing agent, electrometallurgy, this is defined, the which will be the suitable oxidizing or reducing agent. This is always and always identified with the help of this series. So since has its industrial value, that's why this is taken as a very important concept. So this is first application of the electrochemical series. Now I am coming to the second application. The second application is again very important thing for which you have done in the entire study of the electrochemistry, right? Sometimes if you cannot measure the electrode potential or the cell potential of any of the galvanic cell, with the help of this series, you can calculate the value of standard cell potential. I think, my dear students, what is the second? It's used calculation of standard cell potential. This is the second important application of this electrochemical series. Ultimately, this series has been planned or studied for the shape of the galvanic cell and the electrolytic cell. So that's why now I think you all remember that the E naught cell is equal to E naught cathode minus E naught anode. This is the concept we have studied earlier. The cell potential is the difference of the cathodic electrode potential and the anodic electrode potential, and because of this difference only the current flows in the galvanic cell. There is an outcome of the flow of electrons as the electrical energy or as the electricity. Now, I'm again giving you one question. With the help of one example, I'm going to illustrate this, right? With the help of electrochemical series, you can calculate the value of the EMF of any of the cell, EMF or cell potential. The two terms are there. I think you know the difference. Whenever no electric current is taken out from the cell, that time the cell potential is defined as the electromotive force or EMF of the cell. Clear? So here, in general, we study, we measure, we find out, we do our things in the terms of EMF of the cell. Now, I have a question. Please note the question, right? See here. This is the question for all of you guys. Calculate the standard EMF of the following cell. One cell is given to you, although I just wanted to give you the verbal expression so that you understand the learning or representation of the cell. But then also for your convenience, since it is the first question of this type, I am giving you the simple question. A cell is represented, zinc is converted into zinc 2 plus ion separated by the salt bridge, and Ag from the solution gets deposited on the Ag electrode. And the value of standard electrode potential of both the species are given here. For the zinc, it is minus 0.76 volt, and for the silver, this is plus 0.80. Now, our task is to find out the cell potential or EMF of the cell. This is our role. Now, what the things you require here? The formula is written here. Now, I'm writing the cell also that it becomes easy for you. Zn 2 plus, separate double lines, always show to the salt bridge, Ag plus Ag. The concentration is given 1 m. That means here you need not to apply the Nernst equation. If this concentration is not 1 molar, in that case you must need the Nernst equation, and this is the application of the Nernst equation. But whenever the standard electrode potential is given, directly the calculation of the electrode potential can be done. Now from this you have to substitute the value of E cathode and E anode. My dear students, if you get confused, the one thing only I want to tell you, you have to write the values in such a way that the value of E naught cell must come positive, right? I know by this representation, you know that this side is always represented by the anode and this side is always represented by the cathode. But if the simple reaction is given, if it is not given in the form of the cell representation, that time also you can find out by your own that which one will behave as an anode and which one will behave as cathode, right? I'm giving you the example. Okay. Now E naught cell. Now I'm treating the Ag as the anode and the zinc as cathode. What is the value of E naught Zn minus E naught Ag? Its value is minus 0.76 and its value is minus here 0.80. Now what you see that both the quantities are negative, so definitely they are going to be added, but the sign will come negative. What the value you will get? You will get the value minus 1.56 volt, and if the value of the E cell is minus, it proves that this cell does not exist, right? That means this is the way by which I just wanted to teach you that how you can identify the anode and cathode, right? Now I'm changing the value, I'm writing in the proper way. E cell, this is equal to, right? E cell, this is equal to E naught cathode minus E naught anode. And I'm substituting the right values now from the cell representation. You can see this is the anode and this is the cathode. Its value is 0.80 minus, now you will write the value with a sign. Please don't forget to write the value with the symbol. You always have to write the value with the symbol, and in the chat I can see the student, especially Shika, she is giving the correct answer minus 0.76. Here you can see its value is 1.56 volt, right? That means this will be the EMF of the cell, and in this way you can calculate the EMF of any of the cell. The very simple way is there, right? How you can calculate, how you can use this electrochemical series for the purpose of calculation of standard electrode potential. And dear students, simply you have to write the values that is given in the table, otherwise it is given in the question. You never need to remember these values. The CBSE and NCRT, it is always aimed for the skill development and development of the brain in such a way that they can apply the knowledge for any condition. They never go for the rote learning. That's why you need not to remember all these values. Always this will be given in the question, and you just have to learn to interpret the data. how the data that is given in your question you can use to find out the correct answer to come to the conclusion that is being asked in the examination, right? Now the second conclusion, first thing that you can do here, the first conclusion is the value of the E naught cell, the EMF of the cell. The second thing that I want to discuss here is the anode and cathode, which will behave as the cathode and which will behave as the anode. Just by seeing the values, you can come to the conclusion which one is the anode and which one is cathode. Here, which value is greater, 0.80 or minus 0.76? 80, this is a greater value, and since this value is greater, it will behave as the cathode, and since here the value of zinc is lesser, it is a smaller number, and because of that the behavior is like the anode. The cat in the cell, which metal, which electrode can be used as the cathode and anode, it can be decided on the basis of the value of the standard electrode potential, the element, the metal with the higher standard electrode potential will be cathode, and the element with the lower value or smaller value of the standard electrode potential will be the anode. So here two things you have learned from this one particular example, right? First, you can identify which element should be used as the cathode and which element should be used as the anode. And you can find out, you can calculate the value of standard electrode potential. For the purpose all this exercise is being done. So this is second very important application of the standard electrochemical series. I think you all have got this, and I just want to request that all of you, dear students, please do the questions given in the NCERT book as well as from any other reference. In the NEET and other exams, JEE mains and advanced, these types of the questions are always asked that identify the anode and cathode with the values. So the concept that you have learned here, what is the key concept? That the element with the higher value of the standard electrode potential will behave as cathode, and the element with the smaller value of the standard electrode potential will behave as the anode. So this is the conclusion, and by just substituting the value in the normal formula, you can write down, you can find out the EMF of the cell. Now I'm moving towards the third application of this electrochemical series. I think you all remember the reaction of metals with acid. Suppose I have dilute HCl and I have been given the aluminium, zinc, copper and the silver, and I have to find out, I have to predict that which of these will produce the hydrogen gas. Hydrogen gas will be evolved by which, right? One thing that I can do here, I have to take the HCl solution, then I have to dip the different metals in that solution. I have to collect the gas and then I have to go for the pop sound experiment. I think you all remember in the test tube, HCl or any of the acid we take, and then we add the metallic pieces and close it with the thumb. In that case, if you bring a burning matchstick or a burning candle near to that, the pop sound burning experience you all have. So either I can go for this kind of the experiment, or just by seeing this series, we can come to the conclusion that which in which case the hydrogen gas will be evolved. And I know you all don't want to do the experiments, although being the chemistry teacher, being a science student, I will always prefer do the experiments, but the time you don't have the time or the facilities, the case you can use this series. So the third application is prediction. And this prediction is about the evolution of hydrogen gas on reaction with metal or different elements, you can say, right? With metal or different elements. Here, in this case, again, we have to use this series. You all can see here is the hydrogen. And this makes a boundary. All the elements which are above to this hydrogen. This hydrogen is here. The standard electrode potential is 0. All the elements which are lying at the superior position or upper place to the hydrogen will not. Again, I am stressing they don't have the ability to produce the hydrogen gas. Why, dear students? You all know that these elements, right, they are oxidizing agent, right? They will try to oxidize, right? But on the same time, you can see the elements below to the hydrogen, right? They can evolve the hydrogen gas on reaction with acid solution. Clear? The very important thing, the conclusion, right? The things that you have to remember, it is only the sequence of the elements. And I promised you students, in my next video, I will give you the mnemonics, or I will provide you the link for the mnemonics of these electrochemical series, right? So there you will not need to mug up this. In the very shorthand way, you will automatically learn the electrochemical series, and this is the task for the day. Today you will work out only on this electrochemical series. If you have the idea of the position, you can come to the conclusion. The application is, I think, 2 applications already you have done, and you must have concluded that it is very and very easy thing. Just by seeing the position, you have to give the answer. You don't need the much interpretation or the calculation also. The calculation is also very small one. So here, what is the parameter? What is the basic concept that you have to use here to solve this type of the question, right? All the elements which are located above to the hydrogen, they will not evolve. Definitely, they will not evolve the hydrogen gas, but the elements which are located below to the hydrogen, they will definitely evolve the hydrogen gas. You can see here the copper, silver, gold, mercury. These are the metals, but they do not evolve the hydrogen gas in the dilute conditions, especially in the lower classes. What we go for the general concept that whenever a metal reacts with the acid, it produces the hydrogen gas. But it is not compulsory for every metal. What the refined way of representing this concept is all the elements which are located above to the hydrogen in the electrochemical series will not evolve the hydrogen gas they are whether they are metal or non-metal. But all the elements below to the hydrogen, they will evolve hydrogen gas. So my question was, if you are allowed, if you do the experiment and you dip the zinc granules, right, nickel, copper and the gold, which of these will evolve the gas? So definitely, I think your answer will be now nickel and zinc. And I just want to tell you something more. Here, calcium, potassium, and aluminium, all they are below to this, right? So this is the thing, this is the basic concept that you have to apply for this type of the questions. Clear? So I think for today, this much work that we have done is enough. Just it's time for a quick review of the class. We just have to summarize, we have to go for a recapitulation before I close the class. What the first thing that we have learned, the electrochemical series. What is the electrochemical series? The arrangement of the elements on the basis of their standard electrode potential that is measured with reference to standard hydrogen electrode, SHE, right? This is called the electrochemical series, and the electrochemical series is used for the different purposes. It has its own importance. Only 3 applications we have studied. Next class I will go for the applications which are left now, which I have not taken up. The first application that I have taken, it is the comparison of oxidizing and reducing property, right? The element which is located at the superior position will be a better oxidizing agent or poor reducing agent, right? The second application that you have studied, it was about the construction of cell and its output in the terms of electromotive force, the on the basis of the values and on the basis of the position, right? By the position, the element that is located at the lower side, at the bottom or at the inferior position will be have as anode, and the element, the electrode with the superior position. And it's not mandatory every time. If I compare the case of zinc and nickel, nickel will be the cathode and zinc will be anode. But if I compare nickel with the lead, here the condition will change. This will behave as the anode and this will behave as the cathode. Clear? So it depends upon the relative position. So which word is important here? Relative position is important here, and by substituting the values of E naught, you can find out the EMF of the cell. And the third application that we have learned today is the prediction of hydrogen gas on reaction with the metals. So today you all will solve the questions given in our book on the concept of these 3 applications, and the next class I will take with the another exam application and next part of the electrochemical series and the other part of the chapter. Thank you and have a nice time.